All right, this is the second video of the Solving Absolute Value Inequalities. So video 2, and we're going to write this problem down. This is example 1 in the book. So we have example 1. If the absolute value of x plus 7 is less than or equal to 2. So now, we did not get a practice one of these on Friday when we were doing kind of our human number line. So, but let's talk about what this is saying. Is that you're saying this entire value has to be less than or equal to 2. Well, up here when it was just x by itself, we figured out that it was a negative 2, between negative 2 and 2. But now we have a value plus 7. So we figured out that this whole value has to be between negative 2 and 2. But then when you add 7 to the number, you want it to be this amount here. So what number do we have to start at in order to add 7 to equal a negative 2? And what number do we need to start at to add 7 to equal a positive 2? So this is what we're looking for. We're looking for this x, this value that you add 7 to get a negative 2 and add 7 to get a positive 2. Well, hopefully, if you don't know, that's like your x plus 7 equals negative 2, subtract your 7. This box, this unknown, has to be a negative 9. So from negative 9, and from 2, this box here has to be a negative 5. So our value, if we plug in, so our numbers have to be between negative 9 and negative 5. Now I'll show you what's going to happen, what the book is doing, but this is why it's doing it, is that it is wanting the final answer between negative 2 and 2. This is hard to do in the hall. But, and then since you're adding 7, you got to think about what number did you add 7 to get this negative 2 and 2. So here's what's really happening. When you have a less than sign, you are saying that x plus 7 can be less than or equal to 2. And it's an and statement. And x plus 7 is going to be greater than or equal to negative 2. Because you wanted all these numbers. This is what's going to throw you a little bit. But you wanted all these numbers between negative 2 and 2. So I know the and statement. We'll put it back together here in a second. But what you're looking for now is you subtract 7, x is less than or equal to negative 5, and x is greater than or equal to negative 9. Now your and statements don't leave it like this. So we can rewrite this and saying it's negative 9 is less than or equal to x, which is less than or equal to negative 5. That means any number between negative 9 and negative 5 will be a solution to this. So pick one. Let's just say negative 6. Negative 6 plus 7, that's 1. And the absolute value of 1 is less than or equal to 2. Okay, pick one that's not in it. Negative 10. Absolute value of negative 10 plus 7, that's negative 3. Absolute value of negative 3, is that less than 2? Well, absolute value of negative 3 is 3, and that is not less than 2. So you know then you have the correct solution set. So here's another way you can do this, if that's too confusing. Notice this is a less than, so here's what you could do. I'm going to put another way. If it's a less than, and everything's away from absolute value sign, here's what I like to do. Since I know this has to be a negative 2, I'm going to go ahead and make it. Let me rewrite this. Sorry about the shadow. Okay, so this is going to be a negative 2. So I'm going to put a negative 2 here, less than or equal to the absolute value. Nope, you know what? I'm going to drop that. X plus 7, less than or equal to 2. If you rewrite it this way, no, that's only when it's less than. Less than 2. If you rewrite that negative 2, that means that value has to be between negative 2 and 2. Then this goes right back to what you've already been doing. Now you have a negative 9, less than or equal to x, less than or equal to negative 5. That's actually what I really prefer versus splitting to an and re-putting, putting it back. So if it's less than, that means that value has to be pretty close together. It's going to be an and statement. Okay, so I'm going to pause this. You're going to have a video 3 for the or statements.